Here we go, guys. Today we are doing conjunctions. Okay, shh. It doesn't mean the same thing as it does in English, although it's kind of related. What do you guys know what conjunctions means in English?
It's to and or
word that combines two, whatever.
And, but, or, yeah.
It's like,
Okay. In math and logic, it just means and. Alright. And what does and mean? It means this. It means the first part has to be true and the second part has to be true. So if I said you guys are freshmen and you take Algebra 1, that's true, right? So and means this and this are both true at the same time. Okay, so what it will look like on this is something like this. X is greater than 1. By the way, the symbol for and in logic statements looks kind of like a capital A, but that's it. Okay, so X is greater than 1 and X is less than 5. What would that include? Yeah, it include 2, 3, 4. So X is greater than 1 normally looks like this, except for we put it down here on the line, right? And X is less than 5 normally looks like this. But when you combine them with an and, you need this to be true and this is true. Where are they both true? Between 1 and 5. So it's not just 2, 3, and 4. It could be 1.1 or 4 and 9/10 or any fraction or decimal. So what the answer looks like, where is it between 1 and 5? Just like that. Does that make sense? Okay, these floating lines are not the answer. They're just like, this by itself looks like that. This by itself, remember this from last week or 2 weeks ago? This by itself looked like this. But when you combine them with an and, that's what comes out. Okay, what if I did, okay, this is where it gets a little trickier. X is greater than 1 and X is greater than 5.
So it's just about the normal X. The X over is greater than 5 is irrelevant.
And would you
You're close.
would you do like a circle and then down?
Okay, so normally X is greater than 1 looks like this, and X is greater than 5 looks like that. All the numbers greater than 5. What numbers are greater than 1 and greater than 5? Is 2 greater than 1 and greater than 5? No, because it's only greater than 1. It's got to be true for both of these. It's got to be this and that. So 2 doesn't work, 3 doesn't work, 4 doesn't. Does 5 work?
Yes. No.
No, because 5 is not greater than 5. Does 6 work? Yeah. So the actual answer is everything bigger than 5.
Oh, sorry, the 1 is irrelevant.
Yeah, all these are irrelevant. So it's kind of, if you think about it like as a picture, it's where they're both at. So it's all these numbers. See where both the graphs are like right in here? So that's the solution. It's these numbers and these numbers. So it's anything bigger than 5. Okay, and then the last case, there's one more.
Dude, I saw cases too. Sorry. It was really love cases. I know you love we were Isaac case.
Okay, so what's X is less than 1 look like? Going that way. What's X is greater than 5 look like? Going that way. What numbers are less than 1 and greater than 5? Nothing. So what would the graph look like? Blank. You could say there's no solution. You guys know the symbol for no solution?
Yes, circle's right there.
Yeah, I think we've done this some.
There was one other time when we did that.
Yeah, there was one other assignment. Yeah, this just means nothing. So these lines up here are not the answer. that's why I didn't put them on the graph. Really, there is no answer on this part, so no solution. Here we go, jumping in. 1 through 22. So these are just graphs. What we're going to do, make sure 2 and 4 are on your graph here. Okay, you got to make it big enough for 2 and 4 to fit on there. Okay, it's did I copy that right? All right. What does x is greater than 4 normally look like?
A circle.
to the right.
Yeah, open circle to the right. Okay, this is not the answer. This is like me showing my work to figure out the answer. The answer is going to be down here on the graph. Okay, what's x is greater than or equal to 2 look like?
Closed circle.
Closed circle going to the right. Okay, what numbers are greater than 4 and greater than or equal to 2?
Anything to the right.
To the right of 4. This is where they are both, see how they're both here? It's got to be this one and that one. So what numbers apply to this one and that one? All the numbers beyond 4. 4 is going to be an open circle because it's not included in this one. Does that make sense?
Yep.
Okay, you can't say like 3 is greater than or equal to 2, but it's not greater than 4, so 3 wouldn't work. So anyway, all the numbers to the right of 4. All right, number 3, x is greater than negative 3. All right, did I write that correctly? So we need at least negative 3 and 1 to be on the graph. Okay, what does x is greater than negative 3 look like?
X, open circle to the right.
To the right. Remember, these arrows kind of match, right? Normally. Unless x is written on the other side, which it rarely, occasionally is. Anyway, all the numbers greater than negative 3 are negative 2, negative 1, 0, 1, all these numbers. X is less than or equal to 1. Close circle at 1. Going less. Can't draw straight lines today. All right. What numbers are greater than negative 3 and less than or equal to 1?
Negative 2, negative 1 is 0.
Yeah, all the numbers in between. Would negative 3 be included?
No, but
No.
2.9.
Would negative 2.9. Would 1 be included?
No, but
Yes.
not.
Because a closed circle means 1 is included in both. So all the numbers oh gosh, can't draw a straight line. Okay, one more of the graphing problems. Of the odds, I mean, x is less than negative 1, and x is greater than. Okay, so x is less than negative 1, so it's going that way. Greater than or equal to 4, it's going that way. So what numbers would work for that? Nothing. So we're just going to leave the graph blank. I guess I'll go ahead and write over here like no solution. Technically, you are supposed to have just an empty graph. Is the answer. All right. So here's what we're going to do. On the rest of these, we're not graphing, but to kind of simplify the answer, a graph is useful. I don't think I'm going to make you guys do this part though. Anyways, we'll talk about that later. Number 7. So we have to solve these. 2x is greater than negative 6. Actually, the right one doesn't need solved. It's just x is less than or equal to 1. Okay. How would I solve this? This is what we did last couple weeks ago. How do I solve this for x? Divide by 2. Is the inequality gonna switch? Do you guys remember that trick?
Nope, because it's not negative.
Right. If I divide by negative 2, the inequality, the greater than, would flip. But if I'm dividing by a positive 2, so it's not flipping. Okay. I am going to let you guys stop here. Maybe in algebra too, I'll make you guys do it right. But this answer does simplify. And even though this is not a graphing problem, the graph will help us. So what numbers are greater than negative 3 and less than or equal to 1? It'd be all the numbers between negative 3 and 1. Okay, it's not a graphing problem. Okay, how can I write this simply? All the numbers between negative 3 and 1. Here's how you do it. Okay, this says x is bigger than negative 3. Negative 3 is less than x, or x is greater than negative 3. And at the same time, x is less than or equal to 1. So this is how you show all the numbers between negative 3 and 1. So this is telling me x is bigger than negative 3, simultaneously it's less than or equal to 1. Does that make sense? Why did I put a line underneath this one and not underneath this one? Because it's equal to on this one, right there, and it's not equal to on this one. Okay, by the way, you could also write this backwards. 1 is greater than or equal to x is greater than negative 3. These are the same thing. So the book wanted you to do this, but it's kind of difficult. So I'm going to let you guys stop right there on that one. On the evens. On the odds, we're going to do it right. Number 9. Whoops, I'm on the wrong line. 4x minus 6 plus 3. Okay, so just solve them separately, kind of like two different problems. Isabel, what would I do to solve this one? Just from here. Trying to get x by itself, so what do I do about the plus 13?
Minus.
Okay, take away 13, that goes away. Negative 5x. You guys know this one? Negative 7 minus 13.
Negative 1.
Alright, then what, Isabel?
You divide by 5.
Divide by negative 5.
So
What
that
happens?
changes this one.
What happens when we divide by negative?
Switch the thing.
The inequality switches. Negative 20 divided by negative 5 is positive 4.
Whoa.
Okay. And then we have one over here. What would this be, Isabel? What would I do? Plus 6. 4x is less than or equal to 16. Then what? So I got, I'll put it down here. X is less than or equal to 4. That's kind of a weird one, because they almost say the same thing. What numbers are less than 4 and less than or equal to 4?
So it would just be less than.
Would 4 work?
Yes.
No, because it doesn't apply to this one. So really it's just all the numbers less than 4. So if you guys were doing it, I would let you stop right here. But the simplified answer would just be all the numbers less than 4. So this is the actual answer. X minus 4 is less than or equal to 4x. X plus 12 is less than. Alright, Bailey, what would I do on this one?
I would move the x to one side, so you could do minus 4x.
It'd probably be quicker, maybe a little less confusing if we move minus the 4x, but it might be quicker if we move the 2x, because there's only x's on the right side.
Yeah.
So if we do that, it'll be one step shorter. It might be more confusing though, because we're used to having x's on the left side, so this might confuse us a little bit. But okay, and then what would I do?
You divide by 2.
Do you guys know what this means?
-2 is less than or equal to x.
Right, -2 is less than or equal to x, or if you read it backwards, x is greater than or equal to -2. So it's the numbers that are bigger than -2. Alright, this one is minus 12, so it's 18 minus 12, x is less than 6. Okay, that's where I'll let you guys stop, but can we do this without me graphing it? So, remember how I read this backwards? X is greater than or equal to -2 and less than 6. What numbers are bigger than -2 and less than 6?
3 and 4 and 5.
All the numbers between -2 and 6. So that'd be like -1, 0. How do I write the numbers between -2 and 6? Well, it's kind of like, let me move this out of the way. This is kind of what's happening. That. You guys follow that? X is bigger than -2 and less than 6. You can say it just in one statement like that. Well, I reckon x minus 3 is less than or equal to x. Yep, same thing. 2x plus.
Or what's an equality?
The less than greater than stuff. 2x plus, it's the same. I think it's just in the B section because there's like a couple no solutions and a fraction, like they're a little bit slightly harder. 2x plus 6 is less than 18. Alright, did I copy it right? Okay. Ashlyn, what should I do on this first one?
Minus the 3.
Well, normally, like if this had said 4 over here, we would add 3. But since there's x's on both sides, remember what I did last time? So if there's x's on both sides, you want to eliminate the x's off of one side. So I subtracted 2x to get rid of this. So all my x's were over here on the right. So what could I do on this one?
You just do 4x minus 1x.
Right, subtract away this x. So 4x minus 1x is 3x. And then what would I do?
And then you divide by negative 3x.
Just divide by positive 3. Positive 3. So, because that's a times 3, so divide by 3, we'll get rid of it. Negative 3 divided by 3 is negative 1. So x is greater than or equal to negative 1. And Ashlyn, what would I do on this one?
You do minus 6, 18 minus 6.
So I get 12, and then what?
And then you divide by 2.
And I get x is less than 6. So this is very similar to the last problem. So this tells me all the x is bigger than negative 1 or equal to, and less than 6. So it's between negative 1 and 6. So how would I write that? Oh shoot, I just remembered something. Maybe let's no, definitely not. Well, I wanted to do 23 through 26, but as a compromise, how about I take off 21 and 22? So 1 through 20, 23 through 26. Someday you'll get it right.
I walked him next year. Like he's gonna change it.
Yeah, it's more like just a straight, like, normal.
If it's like 1 through 20, 1 through 22, like one,
Ain't no way you
like section number, so it can be changed every time. Every time.
It has to be
irregular. We love Mr. Jordan.
Mr. Jordan's
Okay. What number am I on? 15.
15.
Well, I kind of just remember later what the better plan is, as opposed to the first time I look at it. 2x minus 1 is less than 5, 3x plus 2 is greater than negative 4. Alright, Ben, what would I do on this one?
Plus 1.
Ben?
And then divide by 2. And then you would subtract 2. And 75. But you would change the sign.
No?
No, you would.
Okay, we're dividing by positive 3, so the sign doesn't change. Alright, so what numbers are less than 3, 2, 1, 0, and greater than negative 2? Be like the numbers between them. Negative 2 is over here, 3 is over here. Less than 3, greater than negative 2. So it's the numbers between. So it's greater than negative 2. Less than 3.
I want to go home.
You've had enough?
Yes.
About 30 minutes in.
It's actually been like
29.
30 minutes? 35.
20 minutes.
She's been here for. I'll be here an hour and then I'm gonna leave. What? Yeah.
Starting to feel sick.
Yeah, I never got to do
Sick of school.
Oh. Yeah. Well, I legitimately almost died. I go to the doctor. I'm sure.
All right. Chase, what would I do first on this one?
I'll combine 4x and negative 5x.
Right. Yeah, after you do this first step, it's a normal one though. Actually, you probably wouldn't want to copy the original down. 4x minus 5x is negative 1x, or negative x. Okay, now what do we do? Shh. Plus 2. Okay, so we get negative x is greater than 12, then what?
Flip sign, knock off negative.
Well, yes, but what are we doing basically to get rid of the negative?
I
Right? Divide by negative 1. Okay. When you divide by a negative, the inequality switches, and the 12 switches to negative 12. Okay, how about this? This one's easier. How about this one?
add 6.
So that will be 18. 18 divided by 3 is 6. Okay, what numbers are less than negative 12 and less than or equal to 6? You guys know this one?
Oh, 6.
No. Because if I said 5, is 5 less than or equal to 6?
Yeah.
Yes. Is 5 less than negative 12?
Yeah, no.
So it's
There's
actually,
nothing, because it's going that way and one's going that way.
no, they're both going,
Oh, wait, no, they're both
Basically
going.
anything less than.
it's yeah, it's less
Everything
than
else
negative.
goes.
Yeah, okay, again, I'll say it one more time. On the evens, I'm gonna let you guys, like on 8 through whatever, I'm gonna let you guys stop right there.
I feel like I'm half a page with that one.
Congrats. Okay, 19's weird, which is
Yeah, wait.
a nice change of pace.
Pace.
I like weird problems because they make you think a little bit. Okay, 19. There's nothing to solve, so we don't have to do any algebra here. But what does this mean?
No,
Not equal to.
What numbers are not equal to negative 3 and equal to negative 3? What number is not equal to negative 3 and equal to negative 3?
good question.
Nothing. There's 0.
3.
No
It-
solution.
No solution is right. There are no numbers. It's impossible to equal negative 3 and not equal negative 3. It's not possible. So this one is no solution. Is 20 weird like that? No, 20's, you can do it. The answer is, if you simplify the answer, it's slightly weird, but you don't have to simplify it. So 23, this is a little bit different. This is why I wanted to do these here. Okay, this is already a combined inequality. They already put this means kind of two things it means once. It means x plus 4 is greater than negative 2 and x plus 4 is less than 7. Okay, you do not have to write this though. All we need to do is get x by itself in the middle. So you guys see the three sides? There's a left, a middle, and a right side. So how do I get x by itself in the middle?
Subtract 4.
Subtract 4, but guess what? If I do that in the middle, I gotta do it to everybody else. Right. These are actually kind of the easier problems. So negative 2 minus 4 is negative 6. And 7 minus 4 is 3. So that's it. The end. That won't take half a page. Beep, 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 beep. On 25.
Wait, that was just people outside the door that we need to let in.
That's not what that means. No.
No, it's not. That's been going off since like this morning.
It's the fire. It's the fire.
No, I don't think it is. We can
No, I asked
figure it out
Mr.
though.
Bell, he said it's the camera motion thing, so people can know that there's people in the door.
That's not.
That's not it.
That's what
He didn't
said.
say that.
Yes, he did.
Oh,
I
he's,
said, what's that noise? I thought it was like the door opening and stuff, and he said it's the camera motion. So did Case. Case knows everything, so.
okay. On 25, it says this. What are you doing?
Can I look and see if there's somebody at the door?
Nobody's at the door. It's been doing that since.
Exactly.
Okay. What's this right here mean?
I mean, what the absolute value is just
Shh, shh, shh. Absolute value. So it's just worth what? 11. So 25 is 11 less than 3x minus 1 less than 20. All right.
It's like 5 days.
Huh?
What?
It's on Thursday.
Dude, it's in like 10 days.
It's next
Do we
Thursday.
have to be here for Halloween?
I don't know. Stop.
Halloween is not a holiday for the
But
school.
I guess the dress said.
I'm not sure if it's what day of the week it falls on.
Thursday.
Thursday? Is that what you guys just said?
We do not do, we should just pretty much.
Okay. Shelby, how do I get x by itself on this one?
You would add it. Oh my.
Shh. Add what?
The X or the 3.
Well, 3, when it's right next to x, that means multiply. But how would I get rid of a minus 1? Plus 1. Okay, now here's the weird thing. We have to do a plus 1 there and a plus 1 here. Shh. So 11 plus 1 is 12. In the middle, all we have left is 3x. Okay, now what do I do to get rid of the 3? Shh.
You would divide it.
Divide by 3.